students, welcome to the subject of complex variable and partial differential equations. Myself Ankit Acharya, and today we will discuss about how we can find the solution of non-linear partial differential equation. In non-linear partial differential equation in your syllabus there are 4 types. So here we will discuss about our type 1. In this type 1, now you have only 2 variables p and q. So we know that in first order partial differential equations, how many variables? There are 5 variables: p, q, x, y and z. We know that p and q, p is equal to del z by del x and q is equal to del z by del y. X and y are our independent variable, where z is a dependent variable depending upon x and y. Okay, so here now we have total 5 variables, but in this type 1 we have only 2 variables, p and q, where p is equal to del z by del x and q is equal to del z by del y. So let's see how we can find non-linear partial differential equation type 1. So here you can see there are working rules which you have to follow. The first rule is you have to take p is equal to a and q is equal to b in a given equation, right? So let's take p is equal to a and q is equal to b in given equation f of pq, that is equal to 0. After that, our second step is you have to find the value of b in form of a, right, in terms of a, and our complete solution, our complete integral, that is equal to z is equal to ax plus by plus c. So whatever the value of b in terms of a, that you have to put in this equation, in which z is equal to ax plus by plus c. Okay, so let's see how we can find the solution and how we can solve the example for non-linear partial differential equation type 1. So here is the first example. Solve root p plus root q, that is equal to 1. Okay, let's call it equation number 1. Let's take p is equal to a and q is equal to b in equation number 1. So root a plus root b, that is equal to 1, and we want to find the value of b in terms of a. So that's why root b, that is equal to 1 minus root a. So that's why what is your b? B is nothing but 1 minus root a whole square. Okay, b is nothing but 1 minus root a whole square. Now this is the value of b that we have to put in our equation. What is our complete solution? We know that complete solution, that is equal to z is equal to ax plus by plus c. Okay, we know that our complete solution is z is equal to ax plus by plus c. So put this value of b in this equation. So z is equal to ax plus 1 minus root a whole square y plus c. So this is our final solution for the non-linear partial differential equation root p plus root q equal to 0. Okay, let's take one more example. P plus q, that is equal to p into q. So as I told you, you have to take equation number 1. So let's take equation number 1. Let p is equal to a, and q is equal to b in equation number 1. Okay, so a plus b, that is equal to a into b. Now we want to find the value of b in terms of a. So that's why b is equal to what? B is equal to b minus ab. We can say that b minus ab, right, that is equal to minus a. So b we can take as a common. So b into 1 minus a, that is equal to minus a. So that's why b is equal to, we can say a upon a minus 1. So we find the value of b in terms of a, right? And what is our complete solution? The complete solution, as I told you, that z is equal to ax plus by plus c. So that's why z is equal to ax plus by plus c. So this equal to ax plus, what is the value of b? A upon a minus 1 into y plus c. Okay, so z is equal to ax plus by plus c. That is our solution, and we put the value of b in terms of a, we put in this equation. Okay, so we complete our type 1, which is f of pq is equal to 0. Now let's discuss our type 2 equation of the form f of z pq, that is equal to 0. Now as I told you that we have total 5 variables x, y, z, p and q in first order partial differential equation, where x and y are independent variables, z is a dependent variable, and p and q are first order derivatives, right? P is nothing but del z by del x and q is nothing but del z by del y. Now in this type 2, now we have 3 variables z, p and q. That means suppose your partial differential equation is non-linear partial differential equation, and in that equation if you have only 3 variables z, p and q, in that case how you can solve, that is our next case. So working rule, you can see that working rules are putting p is equal to a into q. Okay, putting p is equal to, very important, putting p is equal to a into q in the given equation, call it equation number 1. So in equation number 1 we have to take p is equal to aq. Now after that we can find the value of q in terms of z and a. Okay, we can find the value of q in terms of z and a, and from the value of q we can find the value of p also, because p is nothing but a into q. So whatever the value we will get in form of z and a, that you have to put here p is equal to aq, so you will get the value of p, and after that our last step is nothing but you have to solve this equation dz is equal to p dx plus q dy. Okay, that you have to solve. So let's see how we can solve this type of example. So here is our first example. I want to solve this example that z is equal to p square minus q square. Okay, so call it equation number 1. Call it equation number 1. Now p is equal to a into q. Okay, p is equal to a into q in equation number 1 that we want to take. Okay, so z is equal to a square q square minus q square. Okay, and from this equation I want to find the value of q. So z is equal to q square we can take as a common, in bracket now we have a square minus 1. So that's why q square, that is equal to z upon a square minus 1, and that is equal to q is equal to plus or minus, we can take plus or minus square root of z upon a square minus 1. Okay, so this is the value of q, plus or minus square root of z upon a square minus 1. Now we know that what is our p. What is our p? P is equal to a into q. So that's why we can write p is equal to a. What is the value of q? Plus or minus. So we can take plus or minus here, plus or minus a square root of z upon a square minus 1. So this is the value of p. Okay, just remember this two value, right? What is the value of p? P is plus or minus a square root of z upon a square minus 1, and the value of q plus or minus square root of z upon a square minus 1. Now we want to solve this equation. Dz is equal to p dx plus q dy, right? And now we put this two value, the value of p and q, in this equation. So let's see how we can solve. So dz is equal to, as I told you, dz is equal to p dx plus q dy. Okay, so that's why dz is equal to, what is the value of p? Plus or minus a square root of z upon a square minus 1. What is the value of q? Plus or minus square root of z upon a square minus 1 dy, and here we have dx. Okay, now you can see that right hand side root z we can take as a common, so dz upon root z, dz upon root z, that is equal to plus or minus a square root of 1 upon a square minus 1 dx plus or minus 1 upon square root of a square minus 1 dy. Okay, and now we can integration, right, integration on both the side, right. So we know that integration of 1 upon root z with respect to z, that is, we know that 1 upon root z, that is equal to z raised to minus 1 by 2, and when we integrate with respect to z, that is nothing but z raised to 1 by 2 upon 1 by 2. So that's why this equal to 2 root z. Okay, 2 root z. Right side we have only constant, so plus or minus 1 upon square root of a square minus 1 x plus or minus 1 upon square root of a square minus 1 y plus b. Okay, so this is our final solution for our first example of type 2, right. Now let's take one more example. Let's take z into pq, that is equal to p plus q. So as I told you, call it equation number 1. Let p is equal to aq, let p is equal to a into q in equation number 1. Okay, so that's why z a q square, that is equal to aq plus q, right. We just take p is equal to aq in this equation number 1. So instead of this p, you can see instead of this p, now we put a into q. So now we have z a into q square, that is equal to a into q plus q. So that's why z a q square, that is equal to a plus 1 into q. Okay, so 1 q from left hand and right hand side we can cancel out. So that's why z is equal to q is equal to a plus 1 upon z into a, right. So the value of q, that is equal to a plus 1 upon z into a, and now we know that what is our p? P is nothing but a into q. So that's why the value of p, that is a, what is the value of q? A plus 1 upon z a, right. So this a cancel out. So finally what is our value of p? P is nothing but a plus 1 upon z only, right. So the value of p and value of q in terms of z and a, that we get. Now put this two value in our equation, dz is equal to p dx plus q dy. Okay, so let's see, dz is equal to, we know that dz is equal to what? P dx plus q dy. Okay, what is the value of p? The value of p, that is nothing but a plus 1 upon z, and the value of q, that is a plus 1 upon z into a. So put this two value in this equation. So p is equal to, so dz is equal to a plus 1 upon a into dx plus, what is the value of q? The value of q, that is a plus 1 upon az into dy. Okay, see from this two equation, right, a plus 1 upon z. So here we have z, right, here we have z. So a plus 1 upon z dx plus a plus 1 upon az into dy. So now you can see that 1 upon z, this 1 upon z we can take as a common term and we can write on a left hand side. So that's why z dz, that is equal to a plus 1 dx plus a plus 1 upon a into dy, and now integration on both the side, right? So left hand side we have to integrate with respect to z, so integration of z, that is z square by 2, that is equal to right hand side integration with respect to x and with respect to y, so a plus 1 into x plus a plus 1 upon a into y plus b. So in today's lecture we discuss about nonlinear partial differential equation type 1 and type 2. In type 1 only we have two variables p and q. In type 2 only we have three variables p, q and z. Okay, and how to solve nonlinear partial differential equation type 1 and type 2, that we discuss in today's lecture. So thank you.